That was a good start, wasn't it? I was just saying hello and welcome to SpaceBar very enthusiastically, and then Ali reminded me that I was on mute. Welcome everyone to this latest episode of SpaceBar, sponsored of course by the AstroAgency. As many of you are aware, we have and Viasat. I was going to mention them in a minute, but let's have that up there. We have this new format that we're running. It's not so new now, I guess. It's a 1-hour format. We have some guests. You can interact with the guests by sending in questions. You can type them in the box under the video, and we'd love to pose your questions to our experts. You can send a video question if you want. There's the nice hello. Everyone's sending in their hellos. Hello to everybody all over the world. Thank you so much for joining us this evening. Yes, so the other thing to say is that, of course, there's an after party. So I don't know how many of you have been to this new format, SpaceBar, before, but we'll have a chat here on YouTube, and then afterwards there's an after party. It's very much a free-for-all. Everybody logs into Zoom. You'll find we'll have a celebration of everything that's happened in SpaceBar and a good chat. So do log on to the after party. It's lots of fun, and it often lasts into the night. So get yourself your cup of tea and get ready for the for the after party. Yes, a big thank you again to Viasat for being our sponsors. It is really thanks to them that we're able to put the show on for you. So we really appreciate their support. And today, as I mentioned, we have 2 guests to chat with, who I'll introduce briefly in a minute. We also, of course, have our space news. So don't forget, there'll be a space news halfway through, which we're looking forward to. That's with Torsten and Vix. There they are. But to start with, let's just introduce our guests for today. So as I mentioned, we have 2 guests. We've got Ray Fielding. He is head of space sustainability at the UK Space Agency. We also have Thomas O'Sullivan, an astrobiologist and astrophysicist, joining us talking about Enceladus and Europa subsurface chemistry. So very much looking forward to chatting with you both as we go through. As I mentioned, you can use the YouTube live chat to pose questions throughout the session today and submit video questions as well if you want to. We'd love to see those. Thank you very much to everyone that submitted a video question. We have a few of those already submitted. So without any further ado, let's begin by having a chat with Ray Fielding, Head of Space Sustainability at the UK Space Agency. Ray, welcome.
Thank you. It's great to be here. My first SpaceBar.
Ah, great. You haven't been to a SpaceBar before. I have to say, I love your background. Love all the books in the background. That's great. That's what I need. I've got into winter mode, so you have lit the fire, but I like cozy. That.
I'll be lighting mine soon, I think. The weather's certainly changing.
Definitely. You've got a few slides, haven't you, to sort of start off?
I have, yeah. So
sustainability.
Absolutely. So my day job, as mentioned in introduction, is head of space sustainability. What I really wanted to give people is a feel to what space sustainability actually is and why it's important. So the slides here will kind of illustrate some of the points about why this is a growing and pressing area and a concern for the UK Space Agency and the UK government. So here we have what the Earth used to look like in 1957. So in 1957 we had one satellite, very large satellite. You might have heard of it. It was called the Moon, still is called the Moon, until 1957, and then Sputnik launched. But now, 70 years later, we have a somewhat crowded environment, and you can see an artist's rendition now of the objects circling the Earth in 2023. And it's a lot more crowded than it's used to be. And what we have to remember is we've gone from 1957 to 2023 without any real thought or planning to what the effect that human operation has for the space atmosphere. Space, as you know, is big, infinite, but the usable space and the bit which we use as a resource is quite small and constrained. Could I have the next slide, please? So the amount of satellites which we've been launching steadily since 1957 has only been increasing. And this is the composite image of Greenwich in London, of the amount of space debris and space junk. So this is defunct satellites and all sorts of objects from dropped astronauts' gloves and tools to collisions between astronauts, which create fragmentation effects. There's several hundred items which pass over Greenwich 24/7, 365 days of the year. And although this picture is of Greenwich in London, that could be your city, your house. This is happening all of the time. The space debris is ever present and ever constant. And it wouldn't take much of an effect for some of that space debris to realign and maybe, worst case, suddenly start coming down from the atmosphere to the ground that's underneath it. Could I have the next slide, please? So this is a kind of a scene setting about the large-scale space objects which are up there at the moment. And you can see from some of these scores and the countries which have been launching, the amount of dead satellites and dead space junk for that total in the right-hand corner is far outweighs the live and the active satellites at the moment. Because currently, although we've moved to a 25-year deorbit, a lot of the legacy space objects had no deorbit plan and we're still living with that effect now. Next slide, please. Not to be studied too closely, but the takeaway from this is there's lots of large objects up there. This was created in March and it's already out of date with the amount of launches going up. But of pressing concern as well is the small objects. So the objects underneath 10 centimeters are one which are almost impossible to track. And there's the smaller objects, the very small objects, which can still cause considerable damage. They're in the estimated potentially hundreds of millions. And I was speaking to Tim Peake, our astronaut, who relayed a story when he was on the International Space Station about a piece of space debris, a tiny speck of space debris going through one side of the ISS and out of the other. And he was saying if he would have been stood a few feet one way or another, it could have gone straight to an astronaut as well, because this debris is traveling at extreme speed, so even small pieces can be extremely dangerous. Next slide, please. So at the UK Space Agency, we operate a tracking service. This is part of our commitment to operate in space responsibly, and we give this as a free service to all of the UK registered satellite operators. And this is a piece of space junk which we tracked, which is a rocket body. This rocket body was from a Korean launch in 2013, so it's been up there 10 years and finally came down just over the Persian Gulf just over a week ago and impacted on the Gulf. 7/10 of the Earth's surface is water, but 3/10 of it isn't. Next slide, please. And this is another rocket body which came down, which we thought would maybe heading towards Ukraine and onto Russia. So it actually came down and hit Poland, but space junk doesn't really care where it lands. Although it's the risk to human life is fairly small. I mean, humans are fairly small in terms of surface area of what the size of a human compared to the land area of the Earth. But can you imagine the political fallout if the US registered object hit the Ukraine in the wrong area, or even went on to hit Russia? How do you prove that it's not a missile? And that's one example of many examples. And these space debris incidents and space conjunctions are happening almost on a daily basis now. Next slide, please. So this is just another example of the sort of debris which we can see returning. This was washed up on the coast of Australia, a rocket body. Nobody knew that it even hit. It was found by locals on the beach one day, just washed up. Not even sure of its origin. And the next slide, please. This happened about a month ago, where now we're not entirely sure what this is, and getting information out of China can be a little bit difficult. It's either a rocket body or an odd piece of satellite debris which nearly wiped out a Chinese village. It had a cloud of what looked like toxic gas, which escaped from the impact site as well. So these impacts can be extremely serious, and it's not just the impacts which are coming down on the ground, but it's the impacts which happen in space which we're also concerned about. A lot of the services which we rely on for our infrastructure, our general way of life, everybody carries a phone. A lot of those rely on, some of the apps rely on space-based services, rely on reliable satellite service. Now, if satellites start impacting when we want each other and start creating debris, soon we could potentially lose that satellite service, and that will have an impact on our way of life, our economy, and how we go forward, because we are more and more reliant on satellites now, seamlessly, even everything from logistics to how your Amazon parcel gets to your house from its destination origin port from overseas, to things like banking. A lot of banking relies on precision timing, which comes from space-based services. So there's a big emphasis on space sustainability, and hopefully that explains why we consider it such an issue. So what are we doing about it? It's okay to talk about it being a problem. What are we actually doing? I've got a little video now, which if you could play, will explain a little bit about what the Space Agency is doing to tackle some of the problems we face to make space sustainable.
We know the Earth's environment is fragile. We need to realise that the space environment is fragile as well, and we need to ensure we preserve it for future generations.
Imagine that future where your children or your grandchildren couldn't rely on space and satellites like we do today. Imagine they don't have weather satellites or satellites monitoring climate change or GPS satellites guiding them. That's a real possibility if we don't address the issue of space debris today.
The UK has an aspiration to be a leader in space sustainability. So we're working with other nations, the United Nations for instance, to ensure the long-term sustainability through regulation and guidelines. And secondly, we're leading on developing cutting-edge technology so we can operate sustainably in space now and in the future.
We'll rendezvous with these satellites, we'll capture them, we'll give it a big bear hug with our claw-like capture system, we'll pull it down, we'll drop it safely in the atmosphere where it'll burn up.
This is the structural qualification model for the ELSA-M servicer spacecraft, which is an end-of-life servicer for satellites in orbit.
We're encouraging operators to prepare their satellites for servicing, to put a docking plate on board, that therefore we can go and capture that satellite and remove it if it's failed.
We're now at a point with space sustainability where we were with climate change perhaps a few decades ago. So the time to act and ensure space sustainability is now.
Ray, I could talk to you all day about this stuff. This is fascinating. And actually, this is a topic we've touched on in SpaceBar many times because our community are really interested in sustainability, whether it's satellites orbiting or whether it's sustainability of launch platforms and all sorts of things. Before I do launch into the 100 questions that I have for you, I think, Ali, we have a video question. Is that right?
We do. We've got a video question that's come in for Ray. So let me play that one. And lots of questions going on in the chat as well. But here's the video question for Ray.
Perfect.
Hello, my name is Yao. I'm a fourth-year physics student at Durham University. I'm also a Prospero Fellow. So today I would like to ask the question of what is the UK Space Agency's long-term plan in regards to space sustainability?
There's a slight issue here where I have no video
Yeah, we
sound.
didn't hear the sound wasn't up that clip, Ali. We couldn't hear it. Maybe the audience heard it.
Okay, so the
No,
question
we didn't hear
was, what is the
Perfect.
UK specifically doing to help tackle space sustainability?
That's a good starting point.
Absolutely. That is a very, very good question. A lot of things. So we are taking a kind of twin track approach, one through responsible legislation and developing space sustainability standards work. So we're working closely with our international colleagues through the United Nations and also providing a sustainable launch framework and operating framework for those who operate from the UK. I mean, part of the problem of tackling space sustainability is don't cause a problem in the first place. So we're very, very keen to make UK not only an attractive place to operate from, but a very sustainable place. Another thing we're doing is technology. So we're developing a lot of technology options to try and tackle with some of the problems and enable people to operate sustainably in space. So the video showed there our first UK Space Agency national mission, which we hope to launch in 2026. And that mission will remove 2 defunct UK space satellite objects, which are just causing problems in terms of being space debris. It will deorbit them, and then it will return to a stable orbit to be hopefully refueled and then used again for another mission to tackle some space junk. So satellites which dock with other satellites which are not working or cause a space hazard, and then safely remove them. It's not really been done before, and it certainly hasn't been done in the way that we're doing it, as in we're choosing 2 satellites which are really not cooperative. I mean, you can choose safe targets to deorbit, and some of the European Space Agency work is de-risking the technology. We're building on that and going one step further. So the objects which we're tackling are dead. You can't control them, and they're tumbling as well. So very, very difficult objects to tackle, but it helps us develop in the UK the sort of technology which we need if we're going to make a serious difference in active debris removal and operating space sustainably. And behind me, or in front of me, I should say, is an infographic which kind of shows that the depth and the breadth of the investment which the UK Space Agency is making. We're investing over £100 million between now and March 2025 in space sustainability. Everything from making sure that we get adequate defences against space weather, to, like I said, the debris removal missions, space studies, space standards, and the work that we do with the United Nations as well. I could probably talk all day and all night about how we answer that particular question, but hopefully that gives you a feel.
Well, yeah, that is absolutely fascinating. I think, the whole topic, as I said, we talk about a lot. You mentioned this mission that's going to deorbit a couple of large satellites that are tumbling, and that poses incredible challenges in itself. And I can't believe it's going up in 2026. That seems incredibly soon. But my other question, really, we talked about the different scale sizes, and the big satellites are important. We know that if they hit something, they produce thousands of pieces more of debris, so they're significant. But we also presumably need to tackle these smaller objects. What are we doing to try to handle those?
Yeah, absolutely. We do need to work out a way to tackle these, because the last thing you want to do is launch millions of pounds worth of satellites and then have it taken out by a small 1 centimetre object. So the first thing we're trying to do is track them and develop new ways of tracking them to find out where these small pieces of debris are. It's very, very difficult, if not impossible, to track very, very small pieces of debris. The next stage, we're looking to develop technology which doesn't yet exist. Things like perhaps pushing small objects with laser lights to push them down into a safe deorbit to move them out of the way. The technology doesn't yet exist. We operate technology calls where, if you have a great idea about how we can actually tackle some of the smaller debris, tell us. Whether there's funding available, we're open to all suggestions and options. Other than the gigantic space hoover, which could cause some problems with the physics of the thing. But yeah, it's an area we need to explore further. I think we all do on an international basis, need to explore how we tackle these really, really small pieces. And there's literally millions of them.
Brilliant. We've got another
Ali,
audience question for you, Ray. Yeah. Adrian was referring back to one of the pictures I think that you showed us earlier on. Adrian says, pictures like this allocate a full pixel per satellite, but at that scale, even a tiny CubeSat would be many kilometers across. Do these pictures vastly overstate the problem? What are we? How worried should we be?
Yeah, absolutely right. This is an artist's impression, so you can actually see. If this was to scale, you wouldn't see anything. However, I think Arthur C. Clarke summed it well when he was asked what is the biggest threat to spacefaring humanity ventures which he sees just before he died, and he said space debris. There's something called the Kessler effect, the Kessler syndrome, which collisions lead to more collisions, This was kind of explored in the film Gravity, if people remember watching that. But basically, it permeates and creates a cloud of debris, very, very small. Again, not represented by that particular graphic, but small but lethal. So in effect, we potentially could, the worst case, lose all access to space, to be able to leave the planet if this goes catastrophically wrong. As well as this huge economic cost, the last thing which you want to do if you're investing $500 billion or pounds in your latest constellation is to have that constellation destroyed with the catastrophic loss of service, which we rely on for economic and sustainable growth on Earth as well.
I don't know if you can hear me. I hope you can still hear me. I've got a question, actually. You mentioned the international community, and I think strikes me that maybe the UK has or could have a leading role to play in this international community, and the fact that we have to all do something. Like, we can't work alone on this. We need new legislation. We need new regulation. Is the UK a leading player in this area? And if not, why not?
Interesting you to say that, because we'd like to be, and we got ambitions to be a leading player, a world leader. Sometimes an overused phrase, but I think it applies very well to both the ambition and the financial support we're putting into this area. So, as I mentioned, loss of service and the effects that has on society, we need to protect against. We're also the second largest operator of active satellites in the world. So there's a liability angle there. I don't know if many people know, but nation states are actually responsible for the damage stuff that they register may cause, whether that to be services on impact on the ground or to space services. So if your satellite registered in the UK, for instance, collides into others, causes loss and damage, the buck stops with the UK government at the end of the day. So we're trying to ensure against that as well. But we just see this as an area which we want to preserve for current and future generations. So we're very active in the United Nations. We're very active on the international scene. We've actually written into our national space strategy, which was published only a few years ago, that the UK has the ambition to be a world leader in space sustainability. So that has created more funding for us. It's created this potential national mission, which we're scoping up at the moment. And has created a large amount of investment into the European Space Agency for space safety and sustainability as well.
Fantastic. Last one, just quickly. I know we're running out of time, but I just wondered if there are any really innovative ideas on the horizon for how to deal with this problem. I'm sure people have addressed it in all sorts of different ways. Is there any one idea that stands out to you that's maybe not feasible, but interesting?
Stands out to me, I like the idea of reusing the stuff. So almost like a scrap metal facility in orbit, which takes in the space junk at one end and repurposes it into something useful at the other. So it's almost like fully sustainable. But again, as I said, I'm open to ideas. So what ideas would you have, Suzie, about how to prevent and limit this problem from growing further?
It's such a difficult question, and people have talked a lot about bringing things down and then burning up and sending them into graveyard orbits. I'm not a massive fan of sending things into graveyard orbits. That to me, I don't know. I'd prefer things to be removed and, like you say, recycled if possible. But I feel like the idea of swallowing up a satellite and recycling the parts right now is quite a long way away. So, I don't know. I don't have a good answer for this, but I have heard ideas of nets grabbing things, and harpoons and all sorts of interesting ideas. And like you say, we need to capture as many people's suggestions and thoughts as we can, I guess, because someone will come up with something totally crazy, absolutely novel, and it'll blow our minds. And, I look forward to that.
I'm open to audience suggestions as well. Very keen to hear.
Yes, you have good ideas. Put them in the chat. Ray would love to hear them, and you could be part of the next mission. So please do. Ray, thank you so much for joining us. Honestly, we have so many questions that have come through. We could have chatted to you for an hour, but I'm afraid we don't have time. Thank you again for making the time to join us. And right now, we have to move on to our space news with Torsten and Vix.
Welcome everybody to the September edition of SpaceBar News. First up, a leading space sector consultancy firm, Euroconsult, has presented some interesting insights for 2024 space trends at the World Satellite Business Week conference in Paris. Now, according to them, the satellite communication market is expected to grow to $123 billion by 2032. Now, this has been driven by a strong demand for data services. The firm also identified a huge potential for direct-to-cell services, which could connect billions of people who are currently offline. Torsten, I know you know all about this, so I'm going to hand over to you now.
So space investments are coming back. That's very important for us in the entire market. So sure, mainly in the US, that's where it started, but also Europe will have its benefits, and that's great. This message after the dip we saw in the last month. Then they pointed out this shortage of launchers, very important. I mean, we know the disaster that we have here in Europe with our own launchers, but there are few coming up, but there's still an absolute shortage for the demand. The scarcity in human resources was addressed. And I mean, our SpaceBar is putting that up again and again, how to get people into the space sector. And it's an ongoing thing. The good thing for all us in the sector is there are always jobs for us. That's good.
Next up, the European Space Agency has announced their 2023 Rising Star Award winners under their Rising Star initiative. These 20 laureates have been selected based on their business plan, their impact and alignment with ESA's strategic objectives. So the laureates will receive various benefits from ESA, such as increased visibility, networking opportunities and access to commercialization services. What more can you tell us about this, Torsten?
I think it's fantastic. It's fantastic that ESA is recognizing the achievements of these new stars. And there are 20, and you can see this list on the ESA website or on our website as well. But to just pick a few of them, I mean, D-Orbit, D-Cubed, KP Labs from Poland, Latitude, Reorbit, Pangaea Aerospace, Vioma, the exploration company. So there are really this mix of launcher companies combined with on-orbit servicing companies, combined with space sustainability companies. So all of them, and I think that is great. What was ESA's point to do that? I mean, they want to place the ESA commercialization department, the gateway, as a leading hub on the European continent, including the UK here in that case. Yeah, but let's see where that goes. I mean, the ambitions are great, and I'm really support this initiative, but let's see what the outcome is. What is the next step? Because growth needs money, and we see. Even I mentioned before, the investments are coming back. They're still on a completely different level in Europe than we see it in the US. And we see it also with a number of companies at the moment. They are looking over the pond to settle in the US. They got also investments to go there because that's where the market is.
Next story is that there is a new agreement between the UK and EU, which will allow the UK to participate in two major European programs. So that's Horizon Europe and Copernicus. Horizon Europe is the world's largest research and innovation program, and Copernicus is the European Earth Observation Program, which provides satellite data and information services. So the UK was previously excluded from these programmes due to Brexit, but thanks to a bespoke new deal secured by our Prime Minister, Rishi Sunak, the UK can now rejoin them as a fully associated member. This means that the UK researchers can apply for grants, bid for contracts, and join the governance of these programmes. This is great news, obviously, for the UK's science and innovation sector, and it has a long history of excellence and collaboration with Europe. So this sounds like a fantastic step towards providing the UK with more space science funding, Torsten. But what areas will this agreement support in terms of science and industry?
First of all, the younger ones might remember there was a time before Brexit that you have been in this program involved. However, my short statement is welcome back, and I think that's great to have the UK back on the Horizon project, because it's an absolute stunning accelerator for science in these various areas. And it's not just space, it's quantum, it's all of the needed technologies for the future. So I would say it is great to have the UK back. And if it's a bespoke deal, then it's a bespoke deal. I mean, that's politics we all have to deal with. But it is good, and I applaud your Prime Minister to make that happen together.
Okay, well, finally from me is the news that the Pentagon has launched a new website that provides declassified information about UFOs, or unidentified aerial phenomena, as they're now called, as part of its commitment to transparency. The website contains records, videos and photos of UAP sightings and investigations, as well as links to other resources and tools for reporting UAPs. Now, this is a response to the growing demands from Congress for more clarity on UAPs. It also follows the release of 2 reports by the National Intelligence Director's Office that has reviewed hundreds of reported UAP cases since 2021, and this has found that some remained unresolved or unidentified. So that's the last story, and whilst I don't think the term UAP will actually catch on in mainstream reporting, it's better than APs, which obviously would have to be the acronym if everything had been identified. So that's my final thought on this. Anything from you, Torsten?
Absolutely. I mean, that's definitely not my area of expertise, but I usually would say very dry as an answer, it's a drone or a balloon. But however, the cool thing is that our editor-in-chief, Dr. Emma Gatti, was asked by the BBC to join one of their programs on BBC News Online, and she talked an hour on that case and on that new study and this new office. So that's an interesting thing to watch, and I think all of you in the UK can check that on the iPlayer, but where we don't have access to here, on the other side of the channel. So unfortunately, however, that's my 5 cents to that. Thank you, Vix.
Okay, thank you, Torsten. That's all from myself and Torsten. It's going to be an interesting after-show party, I think. Anyway, see you on the next orbit of SpaceBar News, and back to Dallas and Suzie.
Fantastic. Thank you so much, Torsten and Vix, for that update. I'm really sorry that Dallas can't be with us today, because he would have loved that story about UFOs and the Pentagon. So we'll have to bring him up to speed a bit later. There is one more news story, though, which wasn't mentioned, which I just thought I would bring up. It's been hitting the headlines recently, and that is a mission called OSIRIS-REx. So OSIRIS-REx went to asteroid Bennu. These are images taken from OSIRIS-REx. It took a sample of the asteroid, as you can see here, approaching a very small landing site with incredible accuracy, and bringing back a sample of the surface itself. It landed a few days ago in the deserts in Utah. There's a picture of the capsule there. And just a couple of days ago, scientists opened that capsule to observe the fresh material back from the asteroid there. Everyone's very happy. The reason it's so exciting, and the reason we want to go to Bennu, is because it's a relic of the early solar system. And so if you look at the Earth and many other planets, the surface has changed a lot since the early solar system. And so it's not representative of what matter looked like over 4 billion years ago. This asteroid is not. And so we're getting sort of a pristine look at the early solar system, and hopefully some hints at the origin of life. So everyone's pretty excited about that. And indeed, the mission, OSIRIS-REx, it dropped back this sample from Bennu, and it's heading on to visit another asteroid, hopefully in 2029. So that mission is not over yet. So that's a little bit more space news just from the last couple of days. But before I get carried away talking about asteroids, I would love to. Actually, I'm going to bring in our next guest. I'm very excited that we have Tom Sullivan joining us today. He's going to be talking a bit about Enceladus. Tom.
Hi, Suzie. Thanks very much for having me. So, as Suzie mentioned, I'm an astrobiologist and a planetary scientist, and I work at the Freie Universität in Berlin. And a lot of what we do focuses on the icy moons of the outer solar system. particularly Enceladus, one of the moons of Saturn, and Europa, a moon of Jupiter. So I'm going to begin. Ray has spoken to you about some space aspects very close to home. We're going to go very, very far out to the outer solar system. So let's talk about first the wider context of astrobiology. So astrobiology is all about the place of life in the universe. It's concerned with the questions of, are we alone? How common is life? How does life evolve? Where do we find it? Is other life similar to us? And the questions go on. So where do we search for life beyond Earth? Well, we only really have one example of life, which is Earth life. So we have to use what we know about our life at home. And so we have drawn up these 3 keystones to planetary habitability. The first of these is liquid water. Water is essential to all life on Earth. We call it the universal solvent. It's used pretty much everywhere in every organism. All life also needs a source of energy. It needs this to metabolize nutrients, to grow, to transport nutrients inside the organism itself. And it also needs the right elements. We find that all Earth life uses at minimum a set of 6 common elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, or CHNOPS for short. So all in all, we look for places that have all 3 of these properties, both inside and beyond the solar system. And most recently, a new trend has emerged, a very promising trend, and that's the moons of the gas and the ice giants, which harbour massive subsurface oceans of liquid water. And in particular, Enceladus, a moon of Saturn. So at first glance, Enceladus was pretty unremarkable. It's a small moon. It's roughly the size of the US state Arizona in diameter. But the joint NASA and ESA Cassini-Huygens mission arrived there in 2004 and changed everything. So Cassini detected a subsurface ocean on Enceladus. Now, it's not the only moon of the outer solar system to have a subsurface ocean, and it wasn't the first one that we detected. But what's unique about it is that the South Pole, through the icy crust, there is a plume, which is made up of many cold jets that eject frozen ice grains and gases from the ocean below. And so what this plume does is it gives us a free sample, basically, of the ocean, of the interior composition of the ocean, without having to drill through kilometers of ice. And this plume also feeds material into one of Saturn's lesser known rings, the E ring. Now, Cassini wasn't designed to sample material from the plume or from the E ring, but NASA and ESA re-engineered the software of Cassini to allow it to dive through the plume after it was discovered, flying as close as about 25 kilometers from the surface. Cassini sampled material both directly from the plume and also when it flew through Saturn's E ring. And you can see on the left-hand figure here is the place of Enceladus within Saturn's E ring. And now we could never have expected to find what Cassini did when it sampled the plumes. So Cassini had 2 mass spectrometer instruments that sampled the plume material and analysed the composition of both the ice grains and the vapours emitted from the South Pole. And it generated what we call mass spectra. And you can see an example mass spectrum on the right here, which is from one of the most recent discoveries of phosphates. Now, some of the most important Cassini discoveries include hydrothermal activity, which gives us a source of energy. Now, this refers to high temperature, high pressure chemical reactions on the seafloor. And we have a few good indicators of this from Cassini. There are nano-sized silicon particles, which only form under very specific temperature and pressure conditions. We also have the presence of hydrogen, methane, and some other molecules, which can be explained by sort of high temperature reactions extracting material out of the core and ejecting it eventually through the plumes. And the presence of these silicon particles give us some information about the core. They suggest that the core is rich in silicon and also has a degree of porosity to it. It has gaps and holes and cracks that allow water to flow through it, which offers enormous potential for chemical reactions in the core. And you can also see here, I won't bore you by going into detail with it, but a long list of inorganic and organic compounds Organic just means carbon-based, and it's what life on Earth is made up of. So we have a really, really long list and a nice diverse range of interesting compounds. So what makes Enceladus such a good place to search for life? There are a number of factors. First, remember our 3 keystones of habitability. We have the massive ocean of liquid water. We have our energy source, which is hydrothermal activity. And we also have the set of 6 elements, all of which have been detected. A little bit more ambiguity in the case of sulfur, but good indications that there is something to do with sulfur there. Now, we also have this organic rich ocean, which is very, very interesting in terms of the chemistry that it could lead to. And we think, in fact, that it might be a good representation of what the early Earth once looked like. So much as Suzie just mentioned about the OSIRIS-REx mission, again, some interesting origins of life and solar system formation information as well coming from Enceladus. And perhaps one of the more exciting discoveries very recently, phosphorus. In general, phosphorus is thought to be a bit of a problem in terms of habitability. It's not that common in the cosmos, but our team in Berlin, led by Professor Frank Posberg and collaborators also, reanalyzed thousands of spectra from Cassini's cosmic dust analyzer and discovered these phosphates in rather unexpectedly high concentrations. And so what this means really is that Enceladus has overcome what is generally considered the most significant barrier to habitability. And phosphorus itself is vital, again, for life on Earth. It's what makes up cell walls, it forms part of DNA, and it's used in energy transfer processes in organisms, like respiration, for example. So Cassini's mission ended in 2017 when it plunged into the atmosphere of Saturn. But we continue to analyze data from it, and each year we gain more and more insights. The phosphate example coming 6 years after the mission ended, but we're still discovering new things. We also learned enough about Enceladus from Cassini to try and replicate its conditions in the lab. So this is on the left here, our new experiment in Berlin. And what we're aiming to do is recreate the high temperature and the high pressure conditions of the seafloor, where the hydrothermal activity occurs, and investigate the behavior of organics and other materials under such conditions. And hopefully this is going to form part of a much larger experiment simulating the entire ocean. The central figure also shows an experiment that replicates some of our spacecraft data, allows us to generate reference data, which gives us more information about what we really see from Cassini. There's also an upcoming mission to Europa from NASA, the Europa Clipper. I didn't talk about it too much here, but Europa is also a very intriguing prospect for life. For example, we also think hydrothermal activity can occur there. So we're very excited for that mission as well. And whilst there's no missions currently planned for Enceladus, there are a lot of concepts, a lot of proposals. Perhaps most notably the Enceladus Orbolander, the upper right figure here. And so watch this space in the next few years. I would be surprised if you didn't see some movement on the mission front to Enceladus. So then I'd just like to finish with one of my favourite quotes from the late Professor Stephen Hawking that I think is particularly pertinent to Enceladus. It wasn't until we sent a mission that we learned so much about it. Shouldn't we be content to be cosmic sloths, enjoying the universe from the comfort of Earth? The answer is no.
I love that quote. Fantastic. This is but I just wanted to ask briefly, thinking about how life evolved on the Earth and how long it took, basically. We had to have a stable environment for a really long time to get life, especially complex life. We're not thinking there's complex life there, but still, do we believe these subsurface oceans on Europa and Enceladus are stable over very long time periods? And what evidence do we have for that?
So yeah, great question. The short answer is yes. The problem lies in trying to clarify how long the hydrothermal activity, in the case of Enceladus, has been ongoing. Without that, it's limited prospects for habitability. Yeah. There's been a lot of modelling sort of done to try and work out if the observed sort of concentrations and fluxes of what we see in the plume can match up with hydrothermal activity on a long duration. And at the moment, we're not entirely sure the exact nature of the reactions that are ongoing. We have some good insights from lab work and from Cassini, but we're not, as I say, we're not too sure on the sort of exact chemical reactions that are ongoing in the core. But in terms of having the liquid water, generally, yes. What we sort of think maintains these liquid oceans is tidal heating. So much like on Earth, as the moon controls the tides, on these smaller bodies, that generates enough heat, mechanical heat, to allow water to exist in the liquid state. And this has been ongoing for a long, long time, particularly with Enceladus. It interacts gravitationally with some other moons of Saturn as well, which gives us sort of a nice, we can model it backwards kind of and work out the history of the system and sort of work out that Enceladus has been warm enough to allow for liquid water for a long time, and similarly Europa also.
Yeah, fascinating. We have a video question. I don't want to allow it because I want to ask you more, but I think I have a cheat sheet to have the video question. Ali.
Okay, here we go.
Hello, Lenka Pastia, student at the University of Manchester, also Prospero Space Fellow, and I have two questions related to astrobiology for Thomas. First one, in your previous researches for Enceladus in Europe, you're going for hydrothermal activity and behavior of complex organic molecules. Why this one specifically? And second, going for any new planet or moon environment, what would be the three main biosignatures or chem signatures you will look for life detection?
Brilliant. So, Thomas, let me put that question to you. So, looking at other planets and moons, what would be the three main biosignatures or chem signatures you would look for?
That's a great question. Okay, fantastic. So, all of it depends, of course, on the environment where you're looking for life. So let's take the case of icy moons, like Enceladus, like Europa. One of the things that we'll look for are molecules that are involved in life, so biomolecules we call them. And a lot of the time these appear in certain patterns, which lets us distinguish them from a non-biological sample. A good example of this are amino acids. Amino acids are what we call chiral, which means they have a left and a right-handed version. And life on Earth tends to use, well, doesn't tend to, it all does, uses a set of exclusively left-handed amino acids. And so some of the work that we do is to try and clarify how our spacecraft data would look if we obtained a sample that was dominated by either a left or right-handed selection of molecules. So in general, that would be a pretty good indicator. But in general, you want to look for combinations of things. So another thing that we would look for in that sample would be isotopic ratios. Now, isotopes are versions of elements that have different numbers of neutrons in their nucleus. So this makes them heavier or lighter, basically. And life prefers, if you like, to use lighter isotopes. It's less energetically demanding. And so if we had a sample and we found that we had a lot more lighter isotopes compared to the heavier ones, it might indicate the influence of biology again. And generally, we look for these ratios in carbon, in nitrogen, hydrogen, or oxygen, and these kind of molecules. But all of these methods, they can be ambiguous. And the best way, undoubtedly, is to try and capture life itself. And in fact, for Enceladus, some of my colleagues in Berlin have simulated what physical cells would look like if they were captured in ice grains and how we could detect them. And there's some interesting results coming out of that at the moment.
You mentioned something really interesting, which is chirality and the idea that Earth is left-handed or uses these left-handed molecules. And if we found right-handed elsewhere in the solar system, presumably that would tell us that life there evolved completely separately to whatever caused life to form on Earth because this chirality difference. Is that right?
Yeah, I mean, it would be a good indication. Again, it's probably not enough to sort of rule out the possibility of a common origin, but it would be a very, very interesting thing that I think would would draw a lot of financial interest, which would be nice for the research community.
You're a bit like me. I'm longing for a small-sized space weather event every day just to get people's interest, and I'm sure that's the same for you. We've got loads of questions for you. We don't have time to ask them because we're running out of time. but Tom, if you're around for the after party, I know that there's a load of questions that people have asked in the chat that they would really, really love to pose to you. So
absolutely,
if you be available, we'd love to hang on to you for a bit longer. I'm afraid we have to move on, though, to the startup spotlight for this particular spacebar. Ali, over to you.
Good evening and welcome to Startup Spotlight. My name is Andy Campbell, your host for this evening's Spotlight feature, which is intended to be a platform that shines a light on some of the most innovative and promising startups in the space sector today. SpaceBar is all about nurturing a thriving ecosystem where ingenuity, creativity and innovation are celebrated and supported. Startup Spotlight aims to bridge the gap between bright minds with groundbreaking ideas and industry leaders eager to support transformative solutions. Tonight on our panel, we are joined by two wonderful business experts. Nicola Musgrove, who is Entrepreneurial Programs Director at Anchored In, and Jonathan Iriki, Ecosystem Manager at Barclays Eagle Labs, where he supports the space sector. Along with myself, the panel will be giving Ian a light grilling as we ask some probing questions, provide relevant insight, and offer valuable feedback and advice to our brave pitcher. And can I invite Ian from Thistle Rocketry to deliver his 3-minute pitch? Over to you, Ian.
Hi, everyone. Thank you. Realistically, if you want to put a CUBE satellite into space at the moment, then you are dependent on rideshare launches. And for a customer, that means long lead times to join these aggregated payloads. It means a lack of control over where that rocket is going, particularly if you're not the main operator on the launch, and a prolonged maneuvering period where you're going to waste years of the lifetime of your satellite and years of revenue generating potential. Needless to say, the market does not serve CUBE satellites well, and that's a big problem because CUBE satellite constellations make up about 40% of this £19 billion launch industry, making them 2.5 times more popular than the next most popular form factor for space infrastructure. Our customer interviews have confirmed that more than just cheap access to space, they need reliable and precise access to space. And that is exactly what we do here at Thistle. We are developing rapid, dedicated launches for CUBE satellites that can put you where you need to be, when you need to be there. And we're able to do that because of our proprietary fluid-driven pump system, which lets us build small, highly scalable rockets at an order of magnitude reduction in cost. Our service is built on a premium, tailored model, working closely with operators to provide rapid launches. And then we also have a subscription-based network protection service, which ensures constellations against failures and coverage gaps with rapid replacement launches. We're also preparing to commercialize our fluid-driven pump system into secondary propulsion markets as a means of early revenue. To date, we've raised more than £250,000 in innovation funding to support our work, and we've used that to build our tech team and to build our hardware. By the end of this year, we expect to see our fluid-driven pump system fly on a miniature demonstrator launch and to see our 8 kilonewton suborbital test engine fire in preparation for our suborbital demonstrator flight, which will go into development next year. David and I are the founders of the company, and we're masters engineers in artificial intelligence and aeronautical engineering, and we're supported by our development engineers, Daniel and Erik. We're a small, dynamic team specializing in engine development and optimization, and we have years of experience building and testing propulsion systems for rockets. Today, we want you to know primarily that our tech works, our market is hungry, and if you want to invest in the future of launch, then we want to speak to you. Thank you.
Great, thank you so much, Ian. A wonderful, compelling pitch, lots of details in there, and I'm sure our panelists will be ready to jump in with some questions. So if I could maybe ask and invite Nicola, first of all, to start the questioning. Nicola, over to you.
Thanks ever so much. Thank you for the pitch there, Ian. It was really interesting to hear. It was very, very smooth and very well put together. So well done on that one. You mentioned the market size being at 9 billion. I'm curious to understand a little bit more about the demographics of that and how you see that shaping up for your particular projects.
Yes, so sorry, it's 19 billion this year. Rather than 9, but yes, it's that's divided across a number of sectors, but primarily we see the dominant interest going forward being in cube satellite networks. So the reason for that being that they are cost effective to get into because the satellites are small and easy to produce, and the low latency, lower Earth orbits that they're employed in are highly effective as well.
Can I just ask a follow-up question of so what's the size of the market that you're predominantly interested in at the moment?
So it's 40% of that 19 billion.
Great, thank you, Ian. Jonathan, a polished pitch from Ian. What's your initial thoughts and questions?
Yeah, great pitch, Ian. Thank you very much. Really interesting. Yeah, just a few questions for me. I just guess just in the banking side of things, as natural, it goes down around the fundraising so far. You've been successful in raising 250,000 so far. What's your plans to raise any further funds and potentially extend on the team of 3 that you have at the moment as well?
Yes, so we have a team of 4 at the moment, and the fundraising plans going forward. We're currently working on our seed raise. We're targeting a £2 million raise there, and the target date for that is February of next year to close. And then further to that, we'll do a round A raise about 18 months after the successful seed raise, which will be for 10 million, and that will be enough to develop our orbital service within the next 4 to 4.5 years.
Excellent, and beg your pardon, a team of 4. Do you look to expand on that at the moment, or are you looking to have anyone join the team, or do you feel that the team you have at the moment are rightly shaped to bring it to fruition?
We're very pleased with our technical side of things, but we are looking to bring in a financial director just to support with that raise. That's in the immediate term, and then as soon as we have a little bit more money flowing from that seed raise, we'd love to expand the technical team quite dramatically because we have a lot of work to do. We have the skills we need to do it, but we just love a little bit more people power.
Excellent, thank you.
Great, thanks, Jonathan, for those questions. Ian, one of the most important things about any business, of course, are your customers. So I'd like you to tell us and provide a little bit more detail on who your customers might be and what activity you've taken to date to go out and engage and potentially acquire those customers.
Absolutely. So our customers are really anybody who's looking to operate a cube satellite in orbit has a good reason to talk to us. A great example customer for us would be a company like Spire. We've chatted to them quite often about this service, and they've given us a lot of really useful feedback on what it would mean to them. And really, we're talking about bringing value to these operators who want to operate big networks of very small satellites by giving them very good access. So Spire is our early customer, but we have spoken to a number of customers in the industry. Just having these director-to-director conversations, as is quite common in the space industry, feeling out what their needs are and making sure that our service is going to meet those needs when it comes to fruition.
We're going to go to Nicola for some last bits of feedback for yourself in terms of your overall presentation before we close for this evening. Nicola.
So I'd say I thought the overall presentation was really well. You've connected things up really nicely and then developed a nice pitch there. One question that I have from this, though, is there's a lot of people playing in this space at the moment and thinking about how they can make CubeSat launches faster, cheaper, lighter for everybody. How will you differentiate yourselves from the other competitors? That there's going to be quite a crowded space of people saying they're doing similar things. So how do you differentiate yourself going forward?
Our USP is very much around the control that you can have as a customer about having access to space on very, very rapid timelines with our vehicles, which are both simple and tailored to your needs. So really, we'll set ourselves apart by being extremely, extremely customer focused, because from the hardware all the way up to the service, we have built ideal customer relations.
Yep. Yeah, that's a great positive note to finish on. Ian, thank you so much for a fantastic session this evening. So a huge thanks to you. We're going to be incredibly excited to hear about the future progress that Thistle will be making in the coming months. So please, Ian, do keep us up to date on that. Many thanks to tonight's guest panel, Nicola and Jonathan, for your support, questions and guidance for Ian, much appreciated. And as we conclude tonight's spotlight, please do feel free to continue the conversation and collaboration with Ian and the rest of the team over in the after party. And going forward, Spotlight will become a regular feature, so if you see the opportunity to apply and you think you would like to have a pitch, then please make sure you do. Finally, stay tuned for more details through AstroAgency's social media on the upcoming spotlights that we'll have in the future. But for now, that's all from me. Thank you very much, and back to Dallas and Suzie. Thank you.
Great. As we just heard, if you are interested in finding out more about Thistle, then their team will be in the after party. So do log on to the after party on Zoom. There's a link there below the screen somewhere, and do join us. Now, we had so many questions through for Ray and Tom, and we haven't had time to ask them all, but we'd love to just pose a couple more. Ali?
Yeah, let's do that. Here's a great one. This one is coming from Maurizio for Tom. If we focus on finding life indicators that resemble those on Earth, could we miss some life forms that have a different composition or metabolism, such as life based on silica and iron? How much does this approach limit our search for life?
Yeah, it's a great question, and it's something that has been talked about before. It's a good example, Maurizio, about silicon. Once upon a time, people were talking about Titan and the cold temperatures on Titan, which is another moon of Saturn, which doesn't have as much water on the surface. But it does have liquid hydrocarbons. And so people once suggested that maybe silicon can form these bonds in a similar way to carbon, but at lower temperatures. But unfortunately, that idea kind of falls apart a little bit. Silicon is nowhere near as abundant as carbon is in the cosmos, and certainly not in the solar system. It doesn't quite offer the same advantages in terms of bonding either. It bonds very well with itself, but when you try to bring in things like oxygen or nitrogen, it doesn't quite form structures in the same way that carbon does, that makes them so good for building biomolecules. In terms of the idea about iron, it's a great idea, and we do actually have some carbon-based life that feeds on iron. Iron-reducing bacteria are pretty common on Earth, and we've discussed them as a possibility for life in subsurface oceans as well. But in terms of what we look for, we don't really have much of a choice, because it's a balance between striving for the best science you can do and getting the funding for it. So if you can justify your search for life based on terrestrial biochemistry or terrestrial aspects of life, let's say, you've got a better chance of getting the money to do the research you actually want to do. And so that's why we use it to search. Yeah.
Great. And actually, just a quick shout out for another mission, Dragonfly, which will be heading to Titan to tell us a lot more about that system. So looking forward to the arrival of that mission. Thank you, Tom. That was a great answer. People always ask that question, don't they? And it's a really good one. So thank you for that. Ali, another one?
Yeah, I got a question for Ray as well. Catherine would like to know, hi Ray, what is the most pressing problem? Is it space debris or congestion?
Yeah, that's an interesting one, and something we're trying to puzzle out in the Space Agency. By 2030, there's going to be an estimated 30 to 50,000 satellites which are operational. That's not including the dead ones. So for us, a pressing concern is what we call space traffic management, almost like a parallel about how the Civil Aviation Authority operates aircraft and international airspace and the handovers. How do you do that with satellites? Plus, there's going to be so many satellites up there. Currently, they're moved by most manually. But when you think about the numbers of satellites and the potential collisions which could take place, it has to be done autonomously. And that needs to be shared in a system which is accessible and usable by everybody all across the world, not just for the UK, but for the US, the French, European Space Agency. So yeah, the space traffic management is becoming a bigger and bigger topic as we go forward, along with the associated increase in space debris from all of these satellites which are up there. The two are kind of hand in hand.
I mean, Ray, you mentioned in your presentation something like 1.5 million collision alarms per year or something that you're dealing with at the moment. I mean, that's a huge number already. So with these giant constellations and the increase in traffic, that's, yeah, very, very interesting. We are out of time. We cannot pose any more questions, even though we would love to. But Tom, Ray, please join the after party. Thank you so much for giving up your time this evening and joining us. It's been so brilliant to have you along and hear about your subjects. Our next SpaceBar is on Thursday, the 19th of October. It's a week earlier than normal. You can sign up on the link below the video, so please do sign up. Shortly we'll be announcing the guest that will be coming next month. Please do subscribe to the AstroAgency YouTube channel for additional content. Thank you very much for joining us. I hope you're able to join the after party on Zoom, and I look forward to seeing you in October.